Welcome back, everyone. In this lecture, we will introduce functions, function notation, domain, and range of a function. Consider two non-empty sets, A and B. A function is a rule that assigns to each element x from set A exactly one element f of x in B. The part where we say exactly one element is very important. X is called the independent variable or the input of the function, and f of x is the dependent variable or the output of the function. If you put together the set of all inputs, that will form the domain of the function. And if you put together the set of all outputs, that will form the range of the function. In the first example, we will look at a few different rules and we will decide whether each rule is a function or not. If it is, we will also find the domain and range for the function. Starting with the first table, we can see that 0 is assigned to 8, 1 is assigned to 2, 2 assigned to 5, and 3 assigned to 4. Each x is assigned to exactly one f of x. Yes, this is a function. The domain of this function would be the set of all x. That's 0, 1, 2, 3. And the range would be the set of all f of x's. That would be 2, 4, 5, and 8. Let's take a look at the second table. 0 is assigned to 8, 1 to 2, 2 to 5, and 0 to 3. Take a look at 0 to 8, 0 to 3. 0 has been assigned to two different outputs, 8 and 3. This is not a function. Let's take a look at the third table. 0 is assigned to 8, 1 to 2, 2 to 5, and 3 to 8. Each x is assigned to exactly one f of x. Yes, this is a function. Is it okay that the output 8 is used more than once? Yes, this is okay. This is still a function. Domain of this function, 0, 1, 2, 3, and the range 2, 5, and 8. In the next example, we will try to practice a function notation. We're going to look at the squaring function. What does it do? Squares. We will present such function using f of x equals x squared. For any given input x, the output is x squared. Let's do a little practice with this notation. For example, f of negative 2 will be negative 2 squared, that is 4. F of square root 5 would be square root 5 squared, that is 5. F of a plus h would be a plus h squared. What is the domain of this function? So the question is, what would be the set of all x's? X can be any real number. You can square any real number. So domain of this function would be all real numbers. Now range. Range would be the set of all f of x's. What do we know about f of x here? What do we know about x squared here? We know that x squared is never negative. We know that x squared is always greater than or equal to 0. That means f of x is always greater than or equal to 0. So the range of this function would be all the real numbers starting from 0 to infinity. In the next example, we can look at some, say, more real-life example for a function. Let's look at a cell phone plan. Cell phone plan costs $39 a month. This plan includes 400 free minutes, and charges 20 cents for each additional minute. So we would like to set up a function that would present the cost for the cell phone depending on the number of minutes which you have used the phone for. Let's say C cost for the number of minutes x, let x present the number of minutes. So the cost for x number of minutes, C of x, equals, now it depends whether you use the phone for less than or equal to 400 minutes or more. So we are going to define some conditions to say if x is anywhere from 0 to 400, then we pay $39. And if the number of minutes exceed 400, means if x is greater than 400, then we pay 39 plus 20 cents, that's $0.2, times x minus 400. That will give us the number of additional minutes. Let's do a little practice with this. So C of 100, what does this mean? It means the cost for the cell phone if you use it for 100 minutes. That is less than 400. So how much do we pay? $39. C of 400, that means the cost for using the cell phone for 400 minutes. That still satisfies the first condition, and that means we're still paying $39. Now the cost for 480 minutes. Now this is exceeding 400 minutes. So I'm going to use the second formula presented in this function, that is 39 plus 20 cents times 480 minus 400, and that will be $55. This function is called a piecewise defined function, where you see the formula is presented in pieces using conditions. We will check the conditions to decide which part of the formula to use. I'd like to show you another piecewise defined function just so we have a little bit more practice with it. F of x equals 3x plus 1 if x is less than or equal to 0, 2 divided by x if x is between 0 and 1, x squared if x is greater than or equal to 1. Let's do a little bit of practice with this piecewise defined function. For example, we like to find f of 1/3, so we have to decide which condition 1/3 will satisfy. 1/3 is between 0 and 1. So we will use the second formula, that is 2 divided by 1/3. We get 6. F of -2. So which condition would -2 satisfy? The first one. It is less than 0. So which formula do we use? We use 3x plus 1. That's 3 times -2 plus 1, -5. Now f of absolute value of a plus 2. Let's think about this absolute value of a plus 2 to decide which condition that will satisfy. What do we know about absolute value of a in general? That is always greater than or equal to 0. So what do I know about absolute value of a plus 2? That is always greater than or equal to 2. If it is always greater than or equal to 2, then it will satisfy the third condition. That means f of x will be x squared. So f of absolute value of a plus 2 will be absolute value of a plus 2 squared. What is the domain of this function? Domain is the set of all x's. I will look at each of these conditions and look at the interval that each condition will cover. Then we will consider the union of all these intervals in order to define the domain of this function. Starting with the first condition, x less than or equal to 0. So that's everything less than or equal to 0 included in the domain of f. The second interval, everything between 0 and 1. Everything between 0 and 1. And the third interval, all x is greater than or equal to 1. Greater than or equal to 1. So if you consider the union of all these three intervals, we get all the real numbers, everything from negative infinity to infinity. Let's talk a little bit more about finding domain of a function. So how do we find domain of a function if it's not given? We would think about the set of real numbers for which that formula would make sense, by which we mean it would produce a real number. I will use the following two examples to explain this a little bit more. F of x equals 1 divided by x. I would like to think about the real numbers for which 1 over x would make sense. 1 over x would not make sense if x is 0. Division by 0, undefined, so x cannot be 0. I would like to remove 0 from the set of real numbers. The negative real numbers are okay. The positive real numbers are okay. It is only 0 that is not acceptable. So I would present the domain of this function as open negative infinity to open 0, union open 0 to infinity. And g of x equals square root of x. Square root of x would make sense if x is positive or 0, but not negative. So I need x to be greater than or equal to 0 so that g of x would be defined, that it would make sense, that it would produce a real number. That is, all the real numbers greater than or equal to 0. Using interval notation, I have close 0 to infinity. In the next example, we will look at some more complex functions. We will still apply the same idea, the fact that denominator cannot be 0 and the fact that the radicand cannot be negative, but we will make it a little bit more complex. Part A. F of x is 1 over x squared minus x. To make f defined, the denominator cannot be 0, meaning x squared minus x cannot be 0. If I factor this out, I get two factors. So that means x cannot be 0, x cannot be 1. Because for 0 and 1, the denominator will be 0 and f will become undefined. So looking at the real number line, I don't want 0, I don't want 1. Everything else is okay. The domain of this function will be open negative infinity to open 0, union, open 0 to open 1, union, open 1 to infinity. Part B. G of x equals square root of 9 minus x squared. To keep g of x defined, the radicand can't be negative. 9 minus x squared has to be non-negative. There are many different ways we can solve this inequality. Here's one suggestion. You can factor out 9 minus x squared to 3 minus x times 3 plus x. If I want this product to be greater than or equal to 0, that means I need both of these factors to have the same sign, both positive or both negative if possible. So let's see if each case would be possible. If I have 3 minus x greater than or equal to 0 and 3 plus x greater than or equal to 0, here x would be less than or equal to 3 and x greater than or equal to negative 3. Let's see if these two intervals would intersect. Greater than, less than or equal to 3, greater than or equal to negative 3. Yeah, they do intersect. The intersection is close negative 3 to close 3. What about the other case? Could they both be negative at the same time? We can show that can't happen. So if I have 3 minus x less than or equal to 0 and 3 plus x less than or equal to 0, then I have x greater than or equal to 3 and x less than or equal to negative 3, which clearly they do not intersect. So this one will give us no solution. The domain of this function, g of x, will be closed negative 3 to closed 3. Let's take a look at part C. H of t is t divided by square root of t plus 1. Here we have both denominator and radicand. The denominator cannot be 0. The radicand cannot be negative. So in short, t plus 1 cannot be 0. T plus 1 cannot be negative. What is left? Positive. T plus 1 will have to be positive. T will have to be greater than negative 1. That would be an open interval starting from negative 1 open to infinity. Why is it open? Because negative 1 would make the denominator 0, would make h of t undefined. I encourage you to use the exercises in your textbook, the homework questions, to practice function notation, finding the domain and range of a function. This is the end of this lecture.